Welcome to section 4. In this section, we're going to talk about how to combine models. After we've built a model, we often will perform diagnostic analyses to help us interpret the model. And then we determine where a model is more or less accurate. In this section, we're going to extend our model building skills because in this section, we're going to talk about how models should not be viewed as the endpoint, but rather as a position to move forward to improve your models. Specifically in this section, we're going to talk about how to improve individual models by really building more than one model. And there are several ways in which we can improve models. We can improve models by combining different models. We can also improve models by using propensity scores. After that, we'll talk about how to improve models by doing meta-level modeling, which is really taking the results of one model and putting them into another model. After that, we'll talk about error modeling and how to improve models that way. And then finally, we're going to talk about how to improve models by doing boosting and bagging. After that, we're going to change gears, and instead of talking about how to work with categorical outcomes, we'll talk about how to work with continuous outcomes. In this video, we're going to talk about how to combine models. Now, there are many ways in which you can combine models. We're going to talk about a few of them here in the PowerPoint section. I'll talk about a few more of them in terms of the actual demonstration as well. In this example, we're showing how to combine categorical outcomes, and in this case, we're combining them by voting. So you can see, for example, that we've built 3 models in this example. We have the prediction from each model, and then we have the confidence value from each model as well. Now, if we decide to combine these models, let's take a look at the first row. You can see that for the first row, each of these models is predicting that the person is going to leave. So if we end up combining the predictions, we are still predicting that the person is going to leave. And you can see what happens to the confidence values. We take each one of those individual confidence values, we add them all up, and then we divide by the number of values that went into adding up those confidence values. So you can see that the 0.80 plus 0.70 plus 0.60 divided by 3 ends up giving us a final confidence value of 0.70. For the second row, you can see that the first 2 models are predicting that the person is going to leave, but the third model is predicting that that person is going to stay. So because we're combining models by voting, the combined prediction would be that the person is going to leave because it's 2 votes to leave and 1 vote to stay. So that's the prediction. And then the confidence value, what we do there is we take the confidence values of the models that we ended up using in the final outcome, the 0.8 and the 0.8. We take those and we divide by the total number of models that we built, which is 3. So that's why you see that the confidence value is much lower than what we had for any of the individual models. Basically, when you are combining models by voting and you have a small confidence value, that means that there was some disagreement among the models. Now, in this next example, we're again combining categorical outcomes, but we're not doing it by voting, we're doing it by highest confidence. So it doesn't really matter what each of the individual models is predicting. What matters is which model is the one that has the highest confidence value, and that's the one that we're going to go with. So again, you can see that we have 3 separate models, we have 3 separate predictions, and each one of those models has a confidence value. But in terms of the final prediction, the combined prediction, for the first row, we're predicting that the person is going to leave because model 1 had the highest confidence value for that prediction, and that's the one that we're taking. We're taking that prediction and we're taking that confidence value. For row number 2, notice that there are 2 models that are predicting that the person is going to leave. There's only 1 model that's predicting the person is going to stay, but that model is the one that has the highest confidence value. Therefore, we're predicting that the person is going to stay. And in that case, you can see what the final confidence value is associated with model number 3, because that's the model we ended up using. In this example, we're going to show how to combine predictions from 2 different models. Now, I already have my electronics data set. And now I'm just going to go down to the field ops palette and I'm going to connect my data set over to a partition node. Because again, I want to split my data into a training and a testing data set. From here, I'm just going to build my models. So I'm going to go down to the modeling palette and I'm going to choose a neural net model. And since we've already run a neural net model on this data before, I know that I'm going to change my neural net model and I'm going to go over to the build options tab. I'm then going to go down to advanced and I'm going to change the random seed over to 5,000. And again, I'm changing the seed over to 5,000 because I know that this was the model that I had found to be the best in a previous run. I'll click on the Run button. And now we've built this model. Now I'm going to run and build a support vector machine model. So again, I'm going to go down to the modeling palette. I'm going to connect the partition node over to the support vector machine modeling node, and I'll edit that node. From here, I'm going to go over to the Expert tab. I'll click on Expert. I'm going to change the regularization parameter to a 5. I'm going to change the kernel type over to polynomial, and I'm going to change the degree value over to a 2. And again, I'm making these changes because I had run this model previously, and we found that this was the best model that we had created. We'll click on Run again. Now that we've built this model, we're going to connect both models here. So I'm connecting the generated neural net model over to the generated support vector machine model. And now I'm going to go down to the output palette. I'm going to connect the generated support vector machine model over to a table, and then we can just run the table. So if we scroll over to the end of the file, you can see that we have the partition node, and then we have the predictions from the neural net model, or the confidence in those predictions. Then we have the predictions from the support vector machine model and the confidence in those predictions as well. I'll close out of this window. And just to see how well each of these models did, we can go down to the output palette. We can connect the support vector machine model over to an analysis node. We'll edit the analysis node. And I'll click on coincidence matrices. I'll select that and click on Run. You can see that the neural net model on the training and the testing data set, its overall accuracy was around 80% or so. And then you can see the support vector machine model on the training data set, the accuracy was around 84, 85%, and on the testing data set about 80%. And you can see how well we did on both the training and the testing data set in terms of predicting each of the individual categories for each of the models. If we scroll down a little further, we can see that the models themselves ended up agreeing a fair amount of the time. In the training data set, about 88% of the time. In the testing data set, about 87% of the time. And when those models agreed, they were actually correct a fair amount of the time. In fact, a little higher than they were on their own. So this brings us to the point that maybe we can combine these models. So let's do that. I'll close out of this window. And first I'll show you how to combine the models in Modeler, and then we'll talk about how you can combine them outside of Modeler as well. So if I go down to the Field Ops palette, I'm going to connect my support vector machine generated model over to an ensemble node, and I'll edit the ensemble node. Now, the ensemble node knows that it's going to be combining the results of two models because it goes down, looks downstream, and it sees that there are two generated models on the stream. The field that it's going to be using as a target field is the field status, unless if I choose otherwise. I can just choose status as well. Now it's going to filter out generated fields. So the previous fields from the model, it'll filter those out for us unless if we deselect that. We'll deselect it so that way we'll see the results of all of the different models. And then we have to specify how we want to combine the models. Now, there are several ways in which you can combine models. You can combine them by voting, in which case each model gets a vote. And in this case, there are two models, so they would end up being really tied, and then it would end up going into different ways of how you handle ties, which are specified right in here. Another way in which you can combine models is confidence-weighted voting. So rather than one model having a value of 1, or each model having a value of 1 in terms of its votes, the voting power of each model is going to be really based on the confidence value. So if one model has a confidence value of 0.8 and another model has a confidence value of 0.9 on that particular prediction, we're going to go with the highest value. There's also several options regarding propensity values. We'll talk about what propensity values are in the next video. And then finally, we have the highest confidence wins. In that case, we're not really voting each individual model. Instead, we're just going with the model that has the highest confidence value. So in our case, we're going to choose, let's just choose voting. And what we're going to do here is that if there happens to be a tie, we're going to go with the highest confidence. All right, we'll click OK. And now let's take a look at this result. So I'm just going to connect the ensemble node over to the analysis node and run the analysis node. Now, first we have the results of the neural net model. Next, we have the results of the support vector machine model. And then finally, we have the results of the combined model. And notice that the overall accuracy in the testing data set is about 82%. So by combining these two models, the overall accuracy ended up increasing about 2 percentage points, which is great. We're able to improve a model without necessarily doing all that much. We just ended up combining the results of two previous models. Now, that's the way you could do this in Modeler pretty easily. Let's say you had other type of data mining or statistical software. How could you combine models? Let me just show you how to do that. I'll close out of this window. And here what I'm going to do is I'm just going to move the ensemble node up a little bit there. I'm going to go down to the field ops palette. I'm going to connect the support vector machine model over to a derived node. And I'm going to use this derived node to create my new field. I'll edit the derived node, and I'm going to create a new field, and I'll call it combined prediction. You can call it whatever you'd like. And I'm not going to derive this field as a formula. I'm going to derive it as a conditional. And this is what I'm going to tell Modeler. So I'm going to say if the prediction of one model is the same as the other, then we're just going to go with the prediction from either one of those models. So let's do that. I'll click on the expression builder, and I'll scroll down to the bottom of the list here, and I'm just going to select the prediction from the neural net model. So I'm going to say if the prediction of the neural net model equals the prediction of the support vector machine model, I'll click OK. Then what's going to happen is I'll click on the expression builder. I'm going to go with the prediction of the neural net model. I could have gone with the prediction of the support vector machine model, but again, since they equal each other, it doesn't really matter. They both end up being the same thing. Now I can write in my if statement. So I'll click on, so if the two models match up, then what's going to happen is we're going to go with the prediction of the neural net model. But if they don't, then what we're going to do is we're going to choose the model that has the highest confidence in its prediction. So to do that, I'll click on the expression builder again. And in my expression box, I'm going to type in if. I'll put in my parentheses, and then I'm going to use if the confidence value from the neural net model is greater than the confidence value of the support vector machine model. I'll close the parentheses. Then I'm going to go with the prediction of the neural net model. Space, else if, or else, put in parentheses again, if the confidence value in the support vector machine model is greater than the confidence value of the neural net model, then I'm going to go with the prediction of the support vector machine model. Else, and then I'll put in single quotes, 0, and if. So what I'm telling Modeler here is that if the two models do not agree, well then if the confidence value for the neural net model is higher than the confidence value of the support vector machine model, we're going to go with the prediction of the neural net model. Or if the confidence value of the support vector machine model is higher than the confidence value of the neural net model, then we're going to go with the prediction from the support vector machine model. Or else, if none of those conditions apply, then we're going to go with 0. And then we have to end it with that end if statement. I'll click OK. That's already been put in there. I'll click OK again. We can take a look at what that looks like. Let's connect the combined prediction derived node over to a table and run that. We'll scroll over to the end of the file. In the first line, both of the models predicted churn. Same thing with the second and third rows, fourth row, fifth row, the same prediction. And then let's see here. Finally, row number 12. The neural net model predicted churn. The support vector machine model predicted current. The neural net model had a confidence value of 0.8. The support vector machine model had a confidence value of 0.5. We ended up going with the prediction for the model that had the highest confidence value, which in this case was churn from the neural net model, and so forth. So that's the way that works out. If I close out of this window now, I can now analyze that data so I can see how I ended up making that prediction, and what you would end up getting was exactly the same numbers that we had seen in the ensemble node. So again, that's the way that you can end up combining the predictions, in this case of 2 models, but we really could have done this with 3 models, 5 models, 20 models, etc. So that's the basic idea in terms of how you can combine predictions from more than one model.